So I'm John Schwartz. I'm a professor at California Institute of Technology in Pasadena, California. And prior to being at Caltech, I was on the faculty at Princeton University. And it was when I was at Princeton that I started coming to the Aspen Physics Center. So my first summer here was 1969. I applied and was accepted the previous year, but by mistake I went to some summer school in Boulder instead, and that was a mistake. So that's why I started in 69 rather than 68. And since 69, I've come here every summer, except for 1971, which I spent in Europe, but I've been here every other summer since then. Some of my memories of the first summer in Aspen are living in the Alpenblick condominiums up on Mill Street. And one of the things I did that summer was to give a big party at Alpenblick where we watched on television the moon landing, which was kind of fun. I remember the first couple years that I always had offices in houses in the vicinity, not actually on the campus. I remember in particular that one summer my office was in the kitchen of Farney House and my desk was the breadboard. That worked fine.
Physics is done on breadboard.
By 1975, I was convinced that this was a place I wanted to come as much as I could, so I bought my own place at the Gant, and I've used that every summer since then, and I'm very happy that I have it there. The beginning of my stays at the Aspen Physics Center coincided with the development of string theory, which has been my professional involvement since its inception. And so for the past 37 years, I've been working on string theory and doing that every summer here in Aspen. The first workshop that I organized in Aspen was in the summer of 1974. And I organized at that time a workshop entitled, well, the rough title, I'm not precise, was dual resonance models, which is what string theory was called in those days. And there were quite a few people who came to attend that, and it was a very lively and active workshop. String theory had been or dual resonance models have been a very active subject from 1969 through 1974. And rather ironically, it was just in 1974 that it was starting to fall out of favor. And so this was, in a way, kind of its last gasp for a while. It was just in 1974 that I had collaborated with Joel Shirk, who visited me for a half year at Caltech, and then also came here to Aspen that summer. And we had proposed at that time that string theory should be used as a unified theory, a quantum theory of gravity and all other forces, rather than as a theory of the strong interactions, which it had been originally proposed for. But strangely, the rest of the physics community somehow didn't catch on to this for another decade. And so for the decade from 1974 to 1984, it was just me and a few collaborators who worked on string theory before it became popular again. Perhaps the reason that happened was that very few particle physicists were interested in gravity in the 1970s. And now it seems strange because you go to any particle physics meeting and there's lots of discussion about gravity and cosmology and astrophysics and all that kind of stuff. But in the 70s, one was inculcated with the idea that gravity was 10 to the 40th times weaker than the strong force, and therefore you shouldn't talk about it. So that was kind of perhaps the reason why we didn't get more of a welcoming reception for this proposal at that time. Starting in 1979, I began a collaboration with Michael Green, who was then employed at Queen Mary College in London. We crossed paths that summer at CERN. And for the subsequent 5 years, we had a very intense collaboration in which he would spend 3 or 4 months of the year at Caltech. We would be here in Aspen together each of those summers. And in fact, he would even share my condominium. This was before I got married, which only happened in 1986. So from 79 to 84, Michael and I were sharing an office here in Beta Hall, living together at the Gantt, working in Caltech and in Aspen, and working extremely intensely. We were convinced that we were onto something important, and during that 5-year period, every year we would write a few papers describing our most recent breakthroughs and saying to one another, we are convinced that now people will see the light and appreciate that string theory is what they should be doing. And much to our amazement, each time we came out with one of our dramatic new announcements, the community was completely uninterested when it continued going on about their business. So by the summer of 1984, when we were working together here in Aspen and had our next breakthrough, by that point we were a little bit like the boy who cries wolf, wolf. We no longer expected anyone to care what we were doing, but we were nonetheless deriving enjoyment and satisfaction from it. Well, that summer we were sharing an office here in Beta Hall. I remember exactly which one, and I can even show which blackboard we were working on. And we made a discovery that we were really quite excited about. One of the important issues in string theory at that time, well, there weren't very many people interested in string theory, but it was an important issue nonetheless, was whether you could have a consistent theory in which there was parity violation, which was left-right asymmetrical. And this is, of course, crucial if you're going to make contact with the real world, because we know the real world has parity violation. So the problem with theories that are not left-right symmetrical is that they tend to give rise to quantum inconsistencies known as anomalies. And so the fear arose that all of the parity violating or left-right asymmetric string theories might actually be inconsistent as quantum theories. So we had been working several years on investigating this, but we hadn't quite figured out how to do it. And in 1983, there was an important paper by Luis Alvarez Gomez and Edward Witten, which gave us crucial clues on how to go about it. So by 1984, we had all the tools in place. And furthermore, that summer, I was running another workshop here in Aspen, and that workshop was entitled Physics in Higher Dimensions of Space and Time. So the advantage of that was that many of the experts in related topics were here at the center. So whenever Michael and I got stuck on some technical issue, we knew exactly who to run to, be it Bill Bardeen or Bruno Zamino or Steve Schenker or whoever. So we had all these people at hand, which was very helpful. And so everything then fell into place. And we discovered that for just if you just pick some random gauge group, there was indeed an anomaly and the theory was inconsistent. But there was one specific gauge group for which we found that there was a cancellation of the anomalies from different contributions. And that particular group was SO32. So we discovered that in the August of 1984. And it was the workshop was just ending at that point, so we didn't have time to explain it to the audience there. It was all over. However, there was one subsequent event that was amusing, and that was in late August of 1984, there was a physics cabaret held in the Hotel Jerome. And fortunately, these physics cabarets don't take place very often because they aren't very good. But there had been one in 1974, and this was the next one after the 1974 one in 1984. And as far as I'm aware, it was the last one that was ever held. I don't think there's been any since then. So in the 1974 cabaret, a specific role had been assigned to Murray Gell-Mann, in which he was asked in the middle of someone else's sketch to run up on the stage and jump up and down all excited that he had found a theory that explains everything in terms of quarks and gluons, and the quarks can't get out. And so he would get louder and louder and more excited. And then two other physicists dressed in white coats would run up on the stage, grab him, and carry him off as he continues talking. Well, in 1984, when the next Cabaret took place, Murray was no longer available to play this role. He was out of town at the time. So I was asked whether I would be willing to play the role that Murray had 10 years earlier. Well, ironically, this was just after our breakthrough, and so I was very happy to do this. And so I ran up on the stage at the appropriate moment and started getting very excited that the theory that will explain everything was based on strings and with supersymmetry in 10 dimensions, and that the only gauge symmetry for which it would be consistent was SO32. I was getting more and more excited. The guys came up in the white coats, carried me off, just like 10 years earlier. But the amusing thing is that this was the first public announcement of our results, and I was entirely serious. So I've related this to various people on different occasions, and at some point it got written up in the Aspen Times, and so it's a rather well-known episode. When the BBC was filming The Elegant Universe, which is hosted by Brian Greene, they considered recreating this, but then eventually I don't know if they ever filmed it, but if they did, it ended on the cutting room floor, as they say. So there have been major developments in string theory here, and that in particular. And one of the interesting things is I remarked that up from 74 through 84, there were only a few people in the world who were interested in this stuff. They were either Michael and myself or our handful of collaborators, such as Lars Brink from Sweden. And Lars also spent some time here working with us, although not that particular summer. Had he been here in 1984, maybe he would have been party to this too. One interesting thing is that, to our surprise, this result really did get instantaneous acclaim, and perhaps largely due to the influence of Edward Witten, who got very excited about this and is very influential. So shortly thereafter, there were hundreds of people in the world working on this stuff, and by now there are thousands. And every summer since then, there's been at least one workshop on string theory here at the Aspen Center. I've been a co-organizer of a few of them, but most of them go on without my interference. So it's very pleasing that these results have had the impact that they did, and that this field is now considered to be mainstream theoretical physics, and that it's so well supported by the Aspen Center. Somewhere around 1978, 79, 80, somewhere in there, I remember getting a phone call from Dan Friedman asking me whether I was willing to be a general member, or whatever it was called in those days. And by the way, would I also be treasurer? So I said, okay. And so the first year I was assistant treasurer, while I believe Mike Simmons was the treasurer. And then the second year of my membership, I was the treasurer. And I had that position, I guess, for 5 or 6 years. I don't remember exactly. But I do remember that I was still treasurer when all this anomaly business took place. And I think it was around, I guess it must have been 6 years, because it was around 85 that was my last summer of doing it. I think that's right, but one could check that. So one of the things that amused me about the job of being treasurer is that I had to file a tax return for the center each year. Even though it's a nonprofit and doesn't pay any taxes, nonprofit organizations are required by law to file a tax return where they explain in great detail all their financial comings and goings and justify their tax-exempt status. So I had quite a bit of work filling out this return, and the thing that seemed somewhat ironic to me is that I hire an accountant to do my own tax return. But I was doing this for the Physics Center in those days. In the 37 years that I've been coming here, the Physics Center and the town have changed enormously, and I don't think you can really discuss one without the other because they're so intertwined. But in my early years, the only buildings were Stranahan and Hilbert Hall, and then, of course, around 1980, I don't remember exactly, Beta Hall was built, which was a significant improvement. And the new building, Smart Hall, is just wonderful. I think that's a really great building. I'm delighted with it. So the development of the campus, the Physics Center getting title to its own land, these were big, big issues for many, many years. And even though I wasn't centrally involved in all negotiations and all that stuff, I was certainly kept abreast of these issues and took a great interest in them. And I was very happy to see that ultimately favorably resolved. Certainly looking at the center, the big difference there are many big differences from the early years, but some that stand out are the fact that there are just more participants now than there used to be, that they represent a wider range of areas of physics than they used to. In the early years, it was almost all particle physics, and then eventually astrophysics and condensed matter got folded in, but now we're spreading out even into biological areas, and there's always discussion about new topics that might, where the Physics Center could expand its reach. This is, I think, generally good to broaden our scope, so I have no problem with that. One of the things that I found very attractive about the Physics Center in the early years was that it was just a place that you come and do your own thing, and maybe occasionally listen to someone give a lecture about something or other. But by the mid-70s or so, workshops had become very important. I guess the NSF provided some guidance in that direction, that there should be more focus to the programs. And by now, almost all participants choose when they come and when they go by the workshop schedule. This is understandable, and given the realities of the modern world, I don't think you could do it another way. But it's kind of a pity that you don't have more people living by the old model. And I must say, I just come when I feel like it, and if there happens to be a string theory workshop, which there usually is, so much the better, but it's not absolutely crucial to me. So, for example, this week and next week, there is no string theory workshop, but I'm here anyway. The town has changed enormously, too. And I wasn't here in the years when people were herding sheep through the center of town, which I heard about on Saturday. But there were things almost as strange today as that in the early years. It was the period of the Vietnam War, the great antagonism towards hippies, and I remember this, one of the restaurants saying, with a big sign on the door, it said, no hippies served. Those are big issues in those days. I wasn't a hippie, but still I didn't approve of that. It's clear now that the center is in a very secure position in terms of owning its land and buildings, being financially on its own feet. One is always scared by the increasing real estate prices, how the participants are going to be able to afford to come here. It's an extremely expensive place. But remarkably, it seems to work. And the fact that the center is starting to accumulate an endowment gives them a little protection against future rental increases, which are probably an inevitability. Real estate prices have perhaps doubled in the last couple of years, and rentals have not. But I'm sure there's just a time delay, and there's some normal ratio between rentals and equity, and so the rentals are going to go up, and the Physics Center is going to struggle to deal with this, as are all the nonprofit organizations. But I'm sure one way or another, the problem will be satisfactorily dealt with, although I don't know exactly how.
Okay, is there anything else you wanted to say?
Well, I intend to continue coming every summer as I have in the past. I might miss one or two, but I doubt it'll be more than that.